Hey everyone. So welcome to a new unit. We're doing a unit now on non-right triangles and vectors. And this unit, when we talk about non-right triangles, we want to talk about solving a triangle. You'll see this in the directions. They'll say, solve the triangle. And solve the triangle means find all the sides and angles. Okay, so we're going to be looking for all the sides and angles of a triangle. I often find it's helpful in these problems to draw a triangle and then fill in all the bits as I find them. It helps me to keep from forgetting to find an angle or a side. Speaking of angles and sides, across from angle C, we have little c. And across from angle A, we have little a. And across from angle B, we have little b. Sides are always lowercase letters, and angles are always capitalized letters. Okay? You're going to see that a lot going forward. Now, we're going to be solving a triangle, and I kind of want to ask you the question, what's the least amount of information you need to solve a triangle? So, for example, if I give you this 4, 8. How much more information do you need? Can you solve the triangle with those two pieces of information? Well, we've got um, this is the short side in a right triangle, and this is the hypotenuse, and we learned in geometry that when the hypotenuse is twice as big as the short side, that means we're looking at a 30, 60, 90 right triangle. And we could use the Pythagorean theorem to find the missing side. X squared plus 4 squared equals 8 squared, or x squared plus 16 equals 64, x squared equals 48. And when we take the square root of both sides, we get x equals the square root of 48, which is 4 times 4 times 3, or 4 root 3. You might remember the shortcut where you multiply the short leg times root 3 to get the long leg. So it seems like we only needed two pieces of information to do this. But in reality, we were actually using a third piece of information here, and that was the fact that we had a right triangle. So when we have a right triangle, we just need two sides, or remember what we learned in third quarter, if I know that this is 27 degrees, and I know that this is 5, and I'm looking for this, then I could say tangent of 27 equals x over 5, and so x equals 5 tan 27. Hey, degrees. I would take out my calculator now and reset the mode on degrees if it's not already. Okay? 5, 10, 27. This unit that we're working on is going to be very light on radians. I don't know that we're going to see radians in this unit. So I would switch my calculator to degrees. And so I can solve for x by multiplying both sides by 5 and then doing 5, 10, 27 in my calculator. 2.548. Remember always to round your answers to 3 decimal places. Okay, so that's a right triangle trig. I need two pieces of information and the fact that I'm working with a right triangle. Those two pieces of information can be two sides or they can be two angles. You know, if I had a side like a hypotenuse of 6 here, it wouldn't be a 30, 60, 90 anymore, but that doesn't mean I can't find out how big this angle A is. And I could say, hey, I have the adjacent side, I have the hypotenuse, and that means that the cosine of angle A is 4/6. And so if I want to know what angle A is, all I have to do is take the inverse cosine of both sides. And that will end up giving me A equals cosine inverse of 4/6. And I can pull out my calculator and say, hey, what's the inverse cosine of 4/6? And my calculator says 48.190 degrees. 48.190 degrees. I could always remember that these angles are complementary, so I could subtract this one from 90 to find that, but I could also set up another trig equation if I wanted to find B. I could use opposite over hypotenuse to find B. And so I would say the sine of B is 4/6, and then take the inverse sine of both sides. We, though, remember cofunctions of complements are the same. And we see that here. Cofunctions of complementary angles are the same value. So these angles must be complements. So if this one is, if A is this one, then B must be the complement, or 90 minus this one. Okay. But while it's great that we could solve a right triangle given two pieces of information in addition to it being a right triangle, what happens when we're given a non-right triangle? Well, this is different. And so I actually want to go back to geometry for a minute and talk about triangle congruence shortcuts. Triangle congruence shortcuts. Do you remember those? Like side, 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 angle, side, angle, side, angle, and angle, angle, side. We also talked about side, side, angle, which spelled backwards is that word that we don't use in our math class, and we said that this is not a shortcut. And the reason it wasn't a shortcut is that we weren't guaranteed always to have a congruent triangle. So let's take a look first at SSS. So I've got three triangle side lengths here, and I put them together, and they make it a triangle. Okay, and now I'm going to take those same lengths, and I'm going to make a triangle. Is this triangle a different triangle than that? And the answer is no, that these are the same triangles. If we measured these angles or used our trig to find these angles, we would find these angles are the same, and we would find that these angles are the same. So we can only make one triangle when we're given all three sides. All three sides will lock into place and create one specific triangle. But when it comes to something like side-side angle, we were troubled by that because, and let me draw a picture of what's going on here. Side, no. This is not one of my sides. I'm just drawing it. There we go. Or, how about straight? Okay, so this is my given angle, angle A. Here's a side. And then over here, I want to draw another side. Okay, and so let's draw it in two different colors. We'll use red, and we'll say this side. Okay, so there's that third side, and I get a triangle. But is that the only possible triangle? Well, if I take this side length on a compass and swing it over, I'm going to intersect here as well. And so using S sub 2, I could actually get two completely different triangles. I could get this little triangle, side-side angle, or I could get this much bigger triangle, side-side angle. So that's why we didn't use side-side angle or angle side-side when we were doing geometry, because we can't get congruent triangles by using this method. All right, well, what's that going to mean for us today, Mr. Gupta? Well, let me tell you. When we want to solve a triangle and we're given these pieces of information, we're going to use law of cosines, sometimes abbreviated as LOC. And when we're going to solve a triangle and we're given this information, we're going to use law of sines, sometimes abbreviated as LOS. Now, this also law of sines. What happens, though, when we try and use law of sines on this situation is that we might get two solutions. Okay? And so when we're solving triangles, this week we'll be talking about law of sines. Next week we'll be talking about law of cosines. When we talk about solving a triangle, there's actually three types of solutions. There's two solutions, but only in the side-side angle case. One solution is possible and no solutions. We could also get no solutions. And that's what we're going to look at today is finding situations with each of these types of solutions. We'll do two of these and one of these, and then at the end we'll do two of these, and then we'll start our next session by doing more of these, okay? So let's take a look at this thing called law of sines. Here's a triangle. I want to look at a non-right triangle. A, B, C, little a, little c, little b. And I want to draw in this height. Okay, height. Now, so where do I go from here? Well, I know that I've got this triangle here and this triangle here, and I see opposite and hypotenuse. And so I could say that the sine of A was h over c. I could also come from this side and see opposite over hypotenuse and say that the sine of c is h over A. Now, what I'd like to do with each of these equations is solve each equation for h. And to do that here, I'm going to multiply both sides by c. And to do that here, I'm going to multiply both sides by h. So I know that c sine A equals h, and A sine C equals h. And since both of these are equal to h, I can set both of these things equal to each other. And so I can say c sine A equals A sine C. Now what I'd like to do is get all the A stuff on one side of the equation and all the C stuff on the other side of the equation. So I'm going to divide both sides by A, and I'm going to divide both sides by C. And so I end up with sine A over A equals sine C over C. So the sine of the angle over the opposite side. Now notice we've got this little equation here. This is law of sines. But when I drew this triangle, it was kind of arbitrary the way I labeled it. I just as well could have put B here and C up here. And if I had done that, this would be sine of B, sine of B, sine of B. This would be a little b, this would be a B, and so I'd be dividing both sides by B, and I'd get sine B over B. So this is law of sines. And now some students want to use all three of these statements. We're never going to use more than two. You'll either be using these two, or you'll be using these two, or you'll be using this one equal to this one. How do I know which one I'm using, Mr. Cooper? Well, the answer will be what information are you given in the problem? You'll always be given three pieces of information, either two sides and an angle or two angles and a side. That's what we're going to be given these first couple of days. Either two sides and an angle or two angles and a side. And we're going to be asked to either find the missing side or angle as using the law of sines as a way for us to then solve the rest of the triangle. Okay, so, one other thing. Sometimes we see the law of sines written this way, the way I derived it for you, and you don't have to worry about deriving it on your own. Just know the formula. But sometimes we've got A over sine A equals B over sine B, where everything is flipped upside down. And that, why would I want to use this one instead of this one? Well, there's no requirement, oh, I must use this in these cases, or I must use this in these cases. Instead, what I want to say is whatever makes the algebra easier. And so if I'm looking for a side, I often put the sides on top. And if I'm looking for an angle, then I often put the angles on top. But really, you can use either form of these. If you look in the textbook, you'll see both forms used comfortably and interchangeably. So just be aware that that's something that you'll see. Okay, so we've got our law of sines now, and we're only going to ever be using two of these expressions, not all three at the same time. So let's take a look at what a law of sines problem actually feels like. Okay, here's our first one. We've got big C is 65 degrees, and we've got little c is 44, and little b is 32. By the way, here's another clue about law of sines. You can only use law of sines if you are given an opposite side angle pair. And by that, I mean, look, we're given both big C and little c. If I had been given big C, little a, little b, then I can't use law of sines. That's a law of cosine situation, and we'll talk about that next week. Right now, anytime I'm given an opposite side angle pair, I know I'm going to be using law of sines. So let's set up law of sines. It looks like I'm given the two sides and I'm looking for an angle. So I'm going to say that the sine of C over little c equals the sine of, now what letter should I use here? Should I use A? No, because I've been given little b. I want to use big B here. So let's plug in what we know. Sine of 65 degrees over 44 equals sine of big B over 32. So there's our setup. Now solving for B, we multiply both sides by 32. And we can find the sine of B. Now, the sine of B isn't what we're looking for. Remember, we're trying to solve the triangle. And right now, we have these three pieces of information, 65, 44, 32, B, A, and little a. So I need to find this angle, this side, and this angle. Okay, so what I'm going to do is solve this equation. I pull out my calculator and I do 32 sine 65 divided by 44, and I end up with this decimal number, 0.659132936. Please don't round that number. If you round that number, you're guaranteed to get the problem wrong. This is what sine B is equal to. But I don't want to know what the sine of B is. That's the upness for whatever this angle is. Instead, I want to find out what B is, so I'm going to do the inverse sine of both sides. Okay, so I take out my calculator and I do inverse sine of that answer. Oops, and I don't need an LN there. Inverse sine of that answer, and I end up with B equals 41.234 degrees. Okay, so 41.234 degrees. 234, yes. So, how do I find this missing side? Well, I know all the angles of a triangle should add up to 180. So if I do 180 minus 65 minus 41.234, I'll end up with the measure of angle A. So 180 minus 65 minus that angle we just found. Oops. 180 minus 65 minus the angle we just found. And I end up with 73. A equals 73.766 degrees. Great. 73.766 degrees. We're almost done solving this triangle. The only thing we still have to find is side A. Now, remember, we can't use the Pythagorean theorem here because this isn't a right triangle. So rather than reach for the Pythagorean theorem, I'm going to reach for the law of sines again. But this time, I'm going to use A as part of that law of sines. And I'm going to use the given side angle pair. I find that cuts down on mistakes when I do this. So I'm going to say 44 over sine of 65 equals A over sine of 73.766. Notice, because I'm looking for a side, I put the side on top this time. Last time I was looking for an angle, so I put the angles on top. Okay, so I want to solve this equation for A, and to do that, I'm going to multiply both sides by the sine of 73.766 degrees times sine 73.766 degrees. These will cancel, and so this is my expression for side A. Okay, so I want the sine of that angle times 44 divided by the sine of 65, and I end up with 46.613. And so this missing side here is 46.613. Okay, that's solving a triangle. Again, I find drawing a blank, generic triangle, labeling all the givens in it, that helps me remember what I still need to find and gives me a place to put the things when I find them. Okay? So here was law of sines with one solution. Let's take a look at another one. A equals 43 degrees, little a is 81, and little b is 62. Okay, so these are side lengths, there's an angle, I have an opposite side angle pair, so I know I'm using law of sines. If you want, why don't you pause the video now and try this problem. And then when you're done, start the video up again. And I will then go through and do this problem. And you can compare your answer. Okay, pause now. Welcome back. So I'm looking for an angle. I'm looking for big B first. And so I'm going to put angles on top. Sine of 43 over 81 equals sine of big B over 62. And again, it's useful, I find, to have 43 degrees, 81, big B, 62, big C, little c. That graphic organizer to help me figure things out. By the way, this triangle is not drawn to scale. Look, 81 should be much larger than 62. I'm not really worried about that. I'm just going to be working over here, and this is just not meant to be an exact version of my triangle, merely a graphic organizer to contain all the bits of information. Okay, so how do we solve this over here? Well, we multiply both sides by 62. And then we take the inverse sine of both sides. And so sine inverse of 62 sine 43 over 81 equals angle B. I'd probably do that in 2 steps. I would do the 62 sine 43 close parentheses divide by 81 first, and then I would do the inverse sine of that answer, second answer, so you don't have to retype that long decimal string. And I get that angle B is 31.468 degrees. 31.468. Another thing to remember from geometry, that across from the biggest side is the biggest angle, and across from the smallest side is the smallest angle. This angle should be smaller than this angle because the side opposite is smaller than the side opposite the bigger one. Okay, so that's that, and now I want to find big C, and I know that the 3 angles of a triangle add up to 180. So 180 minus the one I just found, minus the one that they gave me, I get 105.532 degrees. Okay, and then finally I use law of sines again to find little c. I'm looking for a side this time, so I'm going to put sides on top. Sine of 43 equals little c over sine of 105.532 degrees. I multiply both sides by the sine to get that c equals 81 sine 105.532 degrees over sine of 43. So let's see what we get there. 81 sine of that angle, close parentheses, divided by sine of 43. And I get 114.432. And it makes sense to me that this is a very large side because this angle was so much bigger than either of these other angles. Remember, across from the biggest angle is the biggest side. So we solved that triangle and got one solution. I hope that went well for you. Let's do some more. Remember, on Wednesday of next week, we'll be taking questions from these first 2 non-right triangle assignments on our assignment calendar. All right, how about I'm given big A is 25 degrees, little a equals 6, and little b equals 20. So I set up my law of sines. Again, I'm looking for a big B. and I do sine of 25 over 6 equals sine of big B over 20. And I know the first thing I need to do after I set up this relationship is to multiply both sides by 20. And so now I have 20 sine 25 over 6 equals sine of B. Well, let's ask our calculator what that is. Oops. 20 sine 25, close parentheses. It's really important to close that parentheses before you divide by 6. Okay, and I get 1.408727539. Does anyone recognize anything interesting about that number? We say the sine of this angle is 1.409. Well, if you don't, let's pull out our calculator and let's actually try the inverse sine. Inverse sine, inverse sine. And so I'm going to get B equals what? Well, if I do the inverse sine of that 1.408727539 number, look what happens. I get an error. And why do I get an error? Sine can't be bigger than 1. Sine can't be bigger than 1. Sine can't be smaller than -1. So anytime you have a value here that's bigger than 1 or smaller than -1, this is going to be a no solution situation. No solution. What does no solution look like? You're trying to find the sine of an angle, and that's bigger than 1 or smaller than -1. So if I had had a negative out in front of here, that wouldn't work either. Okay? Anything between -1 and 1 is going to work, but things that are beyond -1 and 1, not going to work. So this is what no solution looks like on your calculator. And if you don't catch it here, your calculator will prompt you by saying, hey, you've got an error here. Okay? Now, let's wrap this up by taking a look at two solutions. I want to take a look at problems with two solutions and discuss how we would go about finding that second solution. Okay, so, and generally when I'm doing these problems, I'm just given three pieces of information. I don't actually know, is this going to be one solution, no solutions, or two solutions when I'm starting. If you take a look in your textbook, you'll see there's a whole lot of here possible situations for side and side angle. You know, there are so many things to memorize here. You're welcome to if you're comfortable with that. My experience is that 90+% of American students are not interested in trying to memorize these, and they just want a way to figure out if there's a second solution. They already feel comfortable with one solution and no solution, and so let's focus on identifying if there's a second solution. Well, I'm telling us already in this problem that there is a second solution. So let's see about finding it. 70 degrees, little a is 155, and little c is 160. Okay, now, because I know there are two solutions, I'm going to draw two right triangles. As soon as I identify that there's a second solution, I draw a second graphic organizer. And what's going to be true in both of these triangles is that all the given information will be the same. 155, 155, 160, 160. And so this must be big C here, and this must be big B over here, and this will be little b. Now, I want to delineate this angle, and this angle, and this side from this angle, and this side, because when we did the straw thing, we saw two completely different triangles. And because of that, this angle here is not going to be the same as this angle here. It's in that same position, the angle in between the 160 and the 155, between the 160 and the 155, but this angle and this angle are not going to be the same when we get two solutions. And so usually when I'm doing a second solution, I call that a prime. And this would be little b prime, and this would be big C prime. Okay? But let's go first and find our regular solution. Okay, so we know that sine of 70 over 155 equals sine of C over 160. So 160 sine 70 over 155 equals sine of C. Oops, phone is not what I want, calculator is what I want, and so I'm going to do 160 sine of 70 divided by, don't forget to close that parenthesis, 155. And I end up with this. If I do the inverse sine of that angle, I get that big C should be 75.931 degrees. If I subtract from 180 the angle I just found and that given angle, I get that the missing angle, B, should be 34.069 degrees. Okay, so I can fill those in, 34.069 degrees and 75.931 degrees. Now I've got all my angles and I still have one side to find. And so I use the law of sines again, and this time I say the sine of 70 over 155 equals the sine of 34.069, over little b. So b will be equal to 155 sine 34.069 divided by sine of 70. 155 sine of that angle, close parentheses, divided by the sine of 70, and I end up with little b is 92.401. 92.401. Okay, so there's our one solution. But I said in this problem there'd be a second solution. A second solution where the given information would all be the same, but this angle would be different, and this side would be different, and this angle would be different. So let's talk about finding a second solution. To find a second solution. Okay. Remember when we used law of sines originally, the first thing we did was find an angle. So take the first angle you find. In this case, it was big C. In other cases, it might be big A or big B. And it's always going to be an angle that we find first in a side-side angle situation. They've given me the two sides and one angle. I'm looking for the second angle. So take the first angle you find and subtract it from 180. Call this angle prime. So for example, in our last problem, we found big C. Well, I'm going to do 180 minus big C, and that's going to get me this thing called big C prime. So 180 minus 75.931, and I end up with 104.07 degrees. So I put 104.07 degrees here. Now I add these two up. 1, 2, 3. If given angle, that was A in this problem, and prime that was the supplement of the first angle we found, C prime, add up to less than 180 degrees, there must be a second solution. And so what I'm saying here is, if I take that given angle plus the prime that we just found, I get 174.07 degrees. This is less than 180, which tells me there's room for a B prime up here. And to find that B prime, I'm just going to do 180 minus that 174.07 minus the given angle minus the prime angle that I just found. And I get 5.93 degrees. 5.93 degrees. Okay? Notice these are very different. Notice these are very different. These will, well, not C and C prime, but there will be a pair that are always supplements in the two solutions case. So I'm not quite done solving the second triangle. I still need to find little b prime, and so I'm going to have to use law of sines again. So I'm going to say 155 over sine of 70 equals little b over sine of 5.93. So I multiply both sides by sine of 5.93 and divide both sides by the sine of 70. So 155 sine of 5.93, close parentheses, it's so important to do that, divided by the sine of 70, and we get little b is 17.041. 17.041. All right, that's a two solutions case. Let's do one more two solutions case today, and then in the next video, we'll do more of them, okay? So, A equals 40 degrees, little a is 54, and little b is 62. Now, I have no way of knowing when I look at those numbers whether I'm going to have one solution, no solution, two solutions, unless I've memorized this table and I'm comfortable using it. So instead, I'm just going to go about the process of finding a triangle. So I've got 40 degrees and 54 and 62. I've got a big B and a big C here and a little c here. Okay, so I do sine of 40 over 54 equals sine of b over 62. 62 sine 40 over 54 equals sine b. And then when I do this in my calculator, 62 sine 40 divided by 54, I get this number. Notice this number is less than 1, and so I know that there's going to be a solution here. If this were bigger than 1 or smaller than -1, there would not be a solution here. To find that solution, I do second sine to get inverse sine of that long decimal answer. I get b is 47.563 degrees. 47.563 degrees. And to find big C, we do 180 minus the given angle 40 minus the angle that we just found, and I end up with 92.437 degrees. All three of these should add up to 180. I still need to find little c, so I'm going to do a law of sines for that. I'm going to say 62, no, where's my side? Oh, there it is, this side, 54. I'm going to say 54 over sine of 40 equals little c over sine of 92.437. I multiply both sides by the sine, and I get that little c is 54 sine of 92.437 over sine of 40. 52 sine of that answer divided by the sine of 40. And I end up with 80.824. 80.824. Okay, so there's my first solution. But is there a second solution? Is there a second solution? Remember, we said to check for a second solution, take the first angle you find. First angle you find. And subtract that angle from 180. 180 minus 47.563. We're going to call that angle, since this was B, we're going to call this B prime. And so we get 180 minus that angle, 47.563. And I get 132.437 degrees. Okay, so is there a second solution? Well, if the given angle plus prime add up to less than 180, there is a second solution. So let's check that. 180 minus the given angle minus this prime angle that we just found, 132.437, is there room for a third angle? And so I get 180 minus the given 40 minus this 132.437. I get 7.563 degrees. So there is going to be a second solution. The second solution will have all the original information, 40 degrees, 54 over here, 62 here. But our B prime is 132.437. Definitely not drawn to scale. This is big B prime. This is A. And then over here we'll have a big C prime. That's this thing. Big C prime is 7.563 degrees. I still need to use law of sines to find little c prime, but that's not so hard at this point. So I'm going to say that 54 over sine of 40 equals little c over sine of 7.563. I'm going to multiply both sides by the sine of 7.563 to get c by itself. 54 sine of that answer, close those parentheses, divided by the sine of 40, and I get 11.057. Little c equals 11.057. Okay, so that's two solutions. We'll practice all of those a little more tomorrow, and or in the next video. I hope this goes well for you. You probably want to try the first assignment on the non-right triangles assignment calendar now before you move on to the next video. Okay, have a great day.